Okay, welcome to this tutorial. The current time is 14:01. It's a Wednesday of the 22nd of July, and right in front of us here, we've got the sine rule to do, right? So here, quickly, what I'm going to do is, before I even start explaining the theorem itself, what I'm going to do is just simply start and explain where we apply it, what it is, and how to actually use it, right? Because most times you guys just see sine rule and then automatically you start hitting the walls and you don't even have a clue why is it important. Okay, so starting off, we've got the sine rule, right? Or you can say the sine theory, or some people use the word theorem instead of saying a theory, but it's a singular um, theory, so that's what it is. It's a theorem that is based on our trigonometric ratios, right? So as you guys can see here, I've now picked our trigonometric ratios. We've got sine theta is equal to opposite over hypotenuse. We've got cos theta, which is equal to adjacent over hypotenuse, and then we've got tan theta, which is equal to opposite over adjacent. Some people try to use a short abbreviation, which they can then say SOHCAHTOA, and some use a long rhyme, right, that they memorize by saying some old hens cackle and how till old age. Whichever one that you prefer, use it. It's perfectly fine. However, the idea here that is mostly important with this topic is that we are just simply dealing with what? Sine theta, right? Or sine and angle is equal to opposite over hypotenuse. That's the most important thing that you need to think about when you're dealing with the sine rule. So moving on here, what do we have? We say, what is the sine rule? If I could just simply, without a definition or a clear mathematical definition, what we can say, what is the sine rule? What does it do? So we can just say the sine rule is a theorem that uses our what? Uses trig ratios, to determine the size of an angle or side of a triangle that is not right, or that doesn't have a right angle. Or we can say is a theorem that uses trigonometric ratios or trig ratios to determine the size of an angle, size of an angle or side of a triangle. Let's rather say of any triangle, because you can use it with a right angle triangle. So of any triangle. Okay, excuse me. So that's what we have. So here, the idea is we're trying to figure out the size, right? So we're trying to figure out the size of any given angle or side of any triangle. Doesn't matter what type of triangle you have. You can have a right angle triangle. You can apply the sine rule. You can have an obtuse triangle. You can have an acute triangle. It doesn't matter. The idea here is that instead of us thinking about the trig ratios, because think about the trig ratios. When do we use the trig ratios? I'm just going to write it in yellow here. When we have a right angle triangle, right? When we have a right angle triangle, we use trig ratio, right? Right angle triangle, we use trig ratios, but in this case, now we don't have a right angle triangle, or that's what the theorem is used for when we don't have a right angle triangle. So if I then say when do we use it, we have now answered that question there. Mostly when we don't have a right angle. So we don't have a right angle, so what are we not using? We are not using Pythagoras here. So most of the time, having a right angle triangle, if the triangle is right, what can we use? Pythagoras for the sides, and we can use trig ratios for the angles. So here we can then say, when we have a right angle, we can use Pythagoras for sides and trig ratios for angles, as well as sides as well, right? So in this case, we don't have this. This is something that we don't have, right? We don't have the right angle there. So here they say, what are the topics? Okay, we are missing something here. What are we missing? We are missing that, right? What are the topics that make up the sign rule question, right? What are the topics that make up the sign rule question? And in my studies, I've always noticed that you have, first, obviously, you got the trig ratio, trig ratios. We also have what? We also have some algebra, right? Calculating the unknown sides. And yeah, that's about it. So the ratio itself is the sign one that's going to be mostly prevalent, or that is mostly used. It's just a sign. So that's a sign trig ratio. And then with algebra is what? Solving for unknowns. Solve for unknown, right? So we're solving for some unknown side, some unknown angle. I can denote the angles and the sides depending on whatever I want. I could say, look for the side A, right? Small a, look for the side GD, right? So a side of a particular triangle. Or it could even be used in squares and a rhombus and any type of shape that we can actually create triangles in it, right? Okay, so another one that is also important that I'm going to include here is geometry. Please also always remember that you're dealing with what? Geometry. Why am I saying geometry? Because geometry is the study of measuring what? The size as well as the angles of a certain shape. So here, we're just doing a bunch of measurements, right? Of what? Of the sides, two things there. Let me just denote that in a different color. The sides, as well as the angles, right? So what I will ask everyone to do is, in my videos, please always remember, when I write stuff, especially once I'm done with writing stuff and explaining it a little bit more, you're more than welcome to pause the video and then write it down so that you can have it in your memory stored. And then you can go back and actually check your notes and then tweak them the way you choose to do so. So, yes. So let's just quickly start and skim over this again in order for us to understand it properly. So we've got the sine rule, right? The sine rule uses the sine ratio of sine theta is equal to opposite over hypotenuse. And then what does it do? What does it do? It uses trig ratios to determine the size of an angle of a triangle, as well as the size of the side of a triangle, right? And here, the key point is any type of triangle: an obtuse triangle, acute triangle, right angle triangle, isosceles triangle, you name it. Any type of triangle that you have, you can apply the sine rule, and then you can then get your answer. And then here, when to use it? When do we use it? When we don't have a right angle triangle, right? Because when we have a right angle triangle, we can use two things. We can use Pythagoras for the sides, and we can also use the trig ratios for the angles, right? So the trig ratios can then apply, and then we can quickly figure out what we're dealing with. And then, what are the topics that make up the sine rule question? Most of the time, it is the trig ratios, meaning the one that is specifically sine, and then you've got your algebra, meaning you need to solve for some unknown, and then your geometry, where you then have to measure or say with reason, right? So I want to include here that we want to have what? Geometry reasons. Because at times, what I've noticed is some students, they don't think about the geometry part of it. So I give you a certain drawing, and then you start using the sine rule immediately. And then what happens is you now forget that you had what? Some angles of a triangle, you had angles within an isosceles triangle, right? So opposite angle equal to the opposite side, right? Or angles of why am I forgetting this rule? What does it say? It says for an isosceles triangle, the rule that I'm thinking about is equal sides of a triangle have what? Equal angles, right? Meaning that this one here, if I've got equal sides there, then the angles are automatically equal. Or the opposite of that says that equal angles, so I would then start here and say equal angles, right? Equal angles have what? Equal sides. So that's a reason of an isosceles triangle. And what else do we have? We've got, let me just also add some angles of a triangle here. Some angles of a triangle, exterior angle of a triangle. So there are many more, right? Many more reasons to this. So all your geometry reasons can be then written here before you even do anything. Meaning, if I give you something and it has a straight line involved, so suppose I give you this, right? I give you this. And you know that a straight line is equivalent to what? It's equivalent to 180. You can then say x plus y is equal to what? 180, and give me a reason of straight line. Suppose you have this value there. Suppose this was 50. You would then have to transpose the 50 over the bridge, and then you would say that x is then equal to what? 180 minus 50, giving you a value of 130 degrees. And then you give me a reason as STR line. So those are the things that I need students to think about. So before I move on here, I want you guys to take this in, think about what we have here, and then in the next video, I'll then go on into explaining the theorem itself. So this was just us going through the theory, thinking about what it is, or what are we going to be dealing with, and then in the next video that comes through, we can then go on and actually pursue the theory and say, okay, I understand that what I have in front of me is a rule that is based on sine. What does it do? It looks at trig ratios. Which one? The sine trig ratio. What am I going to do? Solve for certain unknowns of what? Of sides as well as angles. And then what am I going to use also? I'm going to use some geometry when necessary, right? And then, yeah, that's it for this video here. The next video is going to then be based on the actual theorem itself. So here's the theorem there.